Yeah. So this may be a small section on base change of polynomials. Base change. Just let me say base change in polynomials. Okay. Sort of Lagrange interpolation is, already in that direction. You see. So let's begin with the problems that we had. That way we can understand. So can you remind me what was the last two problems I think we had given? I mean, some of you would have noted down at least and tried it. Hopefully, all of you. But hmm 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 okay. And this thing x minus one plus t. Good. Yeah. These kind of problems are going to be extremely useful in number theory and all kinds of places. Yeah. So, has anybody worked out the coefficients in any way? See, this is certainly possible. Now, if someone has not done this, then you have not tried to do it. Okay, and or if you've not understood the question, then you should tell me. Otherwise, you should have tried. So anyone has done it? Nobody did it. Is it not? I mean, okay, it may not be very interesting, but I mean, but you should still do it. I mean, then maybe you could find it interesting later a little bit. Uh, None of the coefficients, anyone? Nothing? Then how will I do it? Then I have to do it again, right? You have to do it from the basic again. Then you cannot move to a new thing. You should, come on, someone would have done it. No? So why? So if you have not done it, then why did you not do it? Would you like to tell anyone? What is your personal reason? Yes, now I can hear you. Yes. Good. Okay. A is one. So A is one. That's good. Correct. What is B? Uh, we'll see. I don't think it should be five. Aparna, I don't think it should be five. Mix, it will be a Aparna. You have done. You've okay. No problem. Okay. So Pragdish, what did you say? So it's not going to be five, or is it? Okay. Okay. No problem. So fine. Okay. Ishana, can you something that you can say? Uh, you're doing it now. Okay, good. Okay, then do it now. I don't have a problem. But you should try it and find some time and uh, see. But yeah, I cannot comment because schoolwork is very hectic also. I mean, when I was in school, I didn't find any time for, yeah. Yeah. Okay. Try it now. No problem. That's it. Yeah. So so since Aparna has given me a reason why not able, she's not able, would not was not able to do it. So we will try to begin and try to clear that part so that you can continue to do it. Okay. So if you just expand it, right, then I'll expand it in the proper way. No, D may not, might be 1, we'll see. Uh, okay, yeah. So, but let me first try to work this part out so that you can. Now it looks very boring in a way, I understand, but because there are better ways to do, and we are not able to get that now. This is what you get when you expand the first thing, okay? When you expand the second thing, well, it's just common, this is just calculations. There's nothing to not do here. Okay, so you're getting B as 8. Let's see. We'll take the poles. We'll see it. Yep. And this is B. And similarly, you expand the other things. Now, Aparna, now you can begin to continue. Or you can tell me now what is there, what is the problem. So okay, let me just say this small thing that A is 1 is clear because this is, compare the coefficient of x cube. So A is 1. Now to find the other things, what kind of thing you have to do? You have to look at the coefficient of x squared. Maybe that was slightly confusing for you. So we clear it for you and everyone. Okay. This. And you know then that since this is 5, this should also be 5. Okay. And maybe that is what already Ishana said now that this is 5 plus 3. And so this is 8. Aparna, is that doubt cleared now? Making sense? That it is from the x square terms, because there are the terms that are x square, from those only we can take common, right? Yes, B is 8. Yeah, Aparna, do you see, right? This x square coefficient is minus 3a plus b. That is, even if you take minus 2b, you may get the wrong answer, but you'll get an answer. This thing, and then what would you say? You would say you would say that this is equal to 5. Then that is not a problem, right? I mean, you will get the wrong answer, but you will get some answer. You will get like 8 by 8, and then b will become whatever, minus. It could be negative. So what? Why? Who told you that it cannot be negative? Right? It could be negative. It could be fraction also. We don't know. Okay. So far. So these are the things. And now quickly tell me the other coefficients. Sorry. C is 15. Okay, nice. And what is D? D is 9. So see, it was so easy. 2 minutes work and nobody did it. That's okay, no problem. C is 15 and D is 9. Good. These are the things that we have. What do we learn from this? Is everybody okay with this? Even those who are not in the, I don't know if someone was not there, maybe is in the last class. We just expand the polynomial, compare the coefficients. The easiest thing you could do. And yes, and we are getting the polynomial. Yes. Okay, my first question is this comparing the coefficients business, right? Why is it that the coefficients have to be same? I mean, so if this is x square and this is minus 3a plus b, this is just a drill kind of a digging thing, irritating questions coming. Minus 3a plus b, x square on this side, and 5x square on this side. So from here, why should 5 be equal to minus 3a plus b? Why? Why should the coefficient of x square be same on both the sides? Have I ever said it in class? Yes, I have said it. Yeah. I mean, yes. So if it's not the same, then why will the equality not hold? Why should there be only one way to write the polynomial? And okay, you could say I said it in class, but what I'm saying is a reason for that. Can anybody give a reason for that? Is there a reason? What is it? Or is it just obvious, but what does that mean? Yes, no, that's right. But then you are again assuming that the x squared terms have to be same on both the sides. Why should the x squared terms be same on both the sides? My question is sort of like this. I mean, why can't, so if you write, this maybe look very, very silly, but why cannot these two polynomials, uh, maybe, why cannot these two polynomials be the same? A unique solution, but that's a different thing. I mean, I don't know how different it is unless you can deduce from there, then it's not different. But there's always a coefficient which is unique. Meaning, what does that mean? Coefficient of x. Oh, that is right. But okay, so let's bring, so as Nagesh is saying, let's bring everything to one side. Yes. So you bring everything to one side, and then you sort of see that it becomes that this is equal to 0. So why can this not be equal to 0? So why is that not allowed? Why is that not true? No, but then so what? So it's not that x can be 7 or 0. Okay. All right. So you're getting there that if x is 7 or x is 0, then this is 0. Otherwise, it is not 0. So it cannot always be 0. Okay. So you are viewing the polynomial as a function and you're doing that reasoning, right? So, I mean, that's like going in a very complicated way, right? Well, you can just say in the very beginning that by the definition of the definition of 0 of a polynomial is 0 if and only if all the coefficients are 0 is a definition. Okay, so that 0 polynomial is not the 0 number, right? That's what I've said in the first kind of class on polynomials, right? That the algebra definition of polynomials is that there are just a set of symbols, not as a function view. The function view is useful, the function view is equivalent to this and so on. But if you just view the polynomial as a set of symbols, x cube, x square, x, and then we put some weights to them, and then we add them, meaning we just write it in front. And then there are some rules of addition, rules of multiplication. And then there is a definition of equality, and that says that that basically translates to a definition of 0 polynomial. And that says that a polynomial is 0 if and only if every coefficient is 0. And that is a definition. Okay. Obviously, finally, we came to function view and explained it. I don't mind it. And we have proved that function view is equivalent and so on. But okay, and that is, but it's good to, ask yourself these kind of questions from time to time. And you will see these are, yeah. I mean, okay, so these things are okay. But I mean, we want to really do something more interesting, maybe. But you should appreciate, I mean, these questions are there. These questions are legit questions. These are, they go to the foundations of things and yeah. But we want to, I mean, understand something here. But okay, I mean, we found these coefficients, or maybe I'll just, so write them here again. So B is equal to 8, A is equal to 1. What was C? 15 and D? 9. Okay, good. So these are the things, right? But the question really is, how can we find these things more conceptually? Or do we have to go through this, put in the values and essentially solving equations again? Is there a more conceptual way to do these things? Okay. So, yeah, so I mean, so if I ask you to find D, can you tell me what D is directly without finding A, B, and C? Is there a direct way to find D? That is my question. But that would help you to understand how to find this conceptually. That might help. Direct way to find D. Yeah. So you can use a function view. I mean, this is like functions. You could put values. What value should you put in place of x to find D? Come on. 0, 1. That's right. Let's put x equal to 1 on both sides and you get the D. Is there any confusion with that? No, right? And what is D? D is the remainder when this polynomial is divided by x minus 1. See that. You can take x minus 1 common, I mean, just conceptually. So I'm writing it now. You don't have to write it at all later. This because it will be clear that you see, it is as if you're taking this polynomial, you're dividing it by x minus 1, you're getting this quotient, and you're getting this remainder, right? Because it's a number, right? So that has to be the remainder. Remainder is 0-degree term. I mean, and it's a unique way to write. So if I'm able to write, that has to be the remainder. It is a remainder, simply put. Does everybody see that that is the remainder? I mean, you can put x equal to 1 and find it. That is clear. For that, you don't have to see that it's a remainder. But do you see that it's a remainder? It's a remainder when the polynomial is divided by x minus 1, right? So that's how you find the D. You divide the polynomial by x minus 1 and find the remainder. You can also find the remainder like this very quickly. But so that's how you find the D. Yeah? So you find the D by put x equal to 1. And then you can see that it comes out to be 9. So D is 9. Now, how do we find the C? So now try to understand that to find the C, I mean, the C would be like, we have to now divide the quotient by x minus 1 and the remainder you get then is C. Yeah. So so D was the remainder when the original polynomial was divided by x minus 1. C is the remainder when the quotient is divided by x minus 1. And B will be the remainder when the quotient of the quotient is divided by x minus 1 and so on. Is that making sense? Right? It should be clear, right? The C is, how do you find it? That will come to it. But the C is the remainder when the quotient, this is the quotient, right? This whole thing is the quotient, right? Is divided by x minus 1. That will be C. You can see that is C, right? So how do you get that? Start your long division process, right? There is synthetic division and so on, which is the faster way of doing the same thing. But just do the long division. So do the long division first, find the quotient. So in this case, you have to find the quotient also. Yeah. There is well, there are better ways always, but so how do you do it? How do you find the quotient? You take x square, right? You get x cube minus x square. You subtract you get 6x square, right? And then you get 2x, then you get, right? Is everybody doing this? So 6x square, 6x square minus 6x, again you subtract, right? You get 8x, then you get 1. See, I'm just match the answer, okay? If I'm going wrong, tell me. So I think I'm going wrong. No. Oh no, it's correct. I'm correct, yeah. And you subtract, you get 9. 9 is the D, that's fine. But this is the quotient. This is this thing. And you have to now divide this by x minus 1 to find the C, the remainder, right? So again, you divide this by x minus 1. Conceptually, it's a very interesting thing, right? It's a quotient of the quotient, right? It's a remainder of the quotient, and the B term will be the remainder of the quotient of the quotient, it's sort of everything divided by x minus 1. So you get 7x. What do you do here? You do 7. 7x minus 7, 15. 15 is your C, right? X plus 1 is the quotient. You divide that again by x minus 1 and look at that will give you the B. Okay. So you divide this. I mean, I know the answer, but still just, writing it. 1. And you get 8. And this is the B. Okay. And then you have 1. And then you divide 1 by x minus 1. Obviously, the remainder is 1. And so this 1 is the A. Final thing is the A. Second last thing is the B. This is the C. And this is the whatever. This is the D. Okay. The main thing is to be able to see that these are going to give you the answer from this thing that we have done. That D is the remainder, and then C is the remainder of when the quotient is divided by x minus 1. B will be the remainder when, right? B will be the remainder when the quotient, the next quotient is divided by x minus 1, because, you take this, you can just write it, right? You write it as x minus 1 times x minus 1 plus B, right? Plus C, x minus 1 plus D, right? So D is the first quotient. When this entire thing is divided by x minus 1, then you look at the quotient, divide it by x minus 1, and divided by x minus 1 and look at the remainder. Look at the quotient, divided by x minus 1 and look at the remainder, that is the B. And the final thing is the A, which is, okay, we know it's 1, but maybe we can put it here. So, yeah, good. This is okay? Huh? I mean, the fact that it has this conceptual meaning is what I'm trying to bring out. And then this is very nice process to do it. Yeah, is it? Please tell me, is it okay? All right. Yeah. So what kind of things do we learn? So we learn that these are unique. Yeah. So I mean, what we know from the beginning, what we know in the beginning, we had that given any polynomial, the coefficients are unique. That is what we sort of just were trying to argue. Okay. The coefficients are unique because, something is 0 if and only if every coefficient is 0, so the coefficients are unique. That's why you could compare the coefficients and so on. But when you write a polynomial with respect to this thing, x minus 1 in the powers of x minus 1, then also the coefficient is unique. Okay. So any polynomial can again be uniquely written using these special monomials, powers of x minus 1. Initially, we had powers of x minus 0 is how we usually write it. So powers of x minus 1, you could take powers of x minus 2, also write the polynomial. Okay. Then these are the exercises. Okay. The problems that usually come in, sometimes you'll get the hint in the question sort of that maybe I should write this polynomials in terms of x powers of x minus 1, because then the coefficients, some pattern may come out. Okay. Which may not be there when I'm writing it just like that, plain simple way. So those are the things. Okay. Yeah. Yeah. We had another question along these lines, right? Let's just do that. I think it will be easier now to do that. Uh, so could anybody tell me what was that problem? Uh, uh, so sorry. So what was the polynomial? I forgot. Can you tell me the polynomial? Okay, thank you. And then what was the, we need to write it, dash, what was the dash? Oh, yes. Okay, okay, I got it. Yeah. These, okay. Plus, so you find those things. Okay. And then, and then, I mean, you need a constant also. So, yeah. So what are these things? So again, we can solve equations and do expand, compare coefficients and do. But are there better ways to do? How do we find the D? That's right. So how do we find the D? Let's put x equal to 1. Right, right. Exactly. And even just from just from the expression, you can see putting x equal to 1 just does it. So you put and you get 9, right? So that's what Nagesh said. And now, so how do we find C? Yeah, so that is sort of the quotient when the quotient is divided by x minus 2, right? If you want to go by that. Does everybody see that, right? I mean, we'll not do it like that. Maybe some of you can already see some better way in this case. But okay. You have, I mean, just to tell you the point, what I'm trying to say is that it is sort of like you have the quotient divided by x minus 2. And that is what C is. This is the quotient divided by x minus 2 is the C. But is there a faster way to find x minus, if you find C? Okay, I don't know if there is. Is there a better way? Put 2. Yes, that's right. Because, so you see, in the earlier problem, we were trying to, so initially, so we have this sort of basis, right, using which you can write every polynomial of degree at most 3. We sort of said, okay, no, I want to write everything using these. Now we are saying, no. I want to write everything using these. I want to use these to write everything. So here we had, when you write it using these, the coordinates were 1, 5, 2, and 1. Initially what we started with. Okay. Then we said, no, let's not, I want to write it using this. And then the coordinates came out to be, okay, again, I forgot as something. It was 9, it was 15, it was 8. Okay, I didn't forget. I didn't forget. Yeah, it's right. This is what it is. And now we want to find the, so you see how the coordinates are changing. Okay. Like the point could be 2, 3, or it could be, 1 by root 2, 1 by root 2, but you could also write it as 1, 45 degrees. The coordinates change when you change the rule of how you make something, locate something. It is like that. Okay. Now we want to find these. Okay, 9. But in this case, because the factors are in such a way, they have different factors, and 0 is that special number, right, where everything just goes and becomes 0. We can exploit the existence of 0 in our number system, right? So you just put x equal to 2, yeah, and these things vanish, right? So what does C come out to be? Put 2 on this side. Yeah, 8. Left hand side becomes 8. Just tell me what it is. 4 plus 1. 33. Sorry, so what's the final answer? 26 or something? I'm getting 26. Is it 26? 30. Oh, 33. Okay. So what is the final thing? Yes, I'll take that. 24. You're getting 24 something else. So what is the final? Anyone else is computed? If I get two answers same, I'll take that. Okay, then I'll take 24. Good. Now in the same way, can you just quickly find the other two? Any one of you, just you know what you have to do. Just find it for me quickly. Twenty-two. What is A? A should be 1, right? Oh, you're getting 11. Just check everybody. What about other people? So this is 24, right? This is, so you can work it out, right? Yeah, only that you have to put a bigger value. So okay, 11. All right, and this is 1. Good. And so this is this calculations. Right? So please do practice of these things. Yeah, this interesting, right? You see, this is just what I wanted to show so far, the time being. These coordinates are changing because we are writing things with respect to different. Yeah. Once again, unique and blah blah blah, right? And These are things. Okay, I'll stop here. I wanted to say a few things. I wanted to connect this with matrices. Somehow, like how would writing like x cube using these and x square using these and x using these and 1 using these, so that is 1. How writing these basic polynomials in terms of these new coefficients, how the thing changes. For example, x cube, what is x cube in the first language, in the first coordinate system? It is 1 0 0 0 0, right? Because it's x cube, right? X square is 0, coefficient x is 0. When you write x cube using these things, then the coefficients will change. You will get some coefficients. If you want to write x cube as, x minus 1 cube, you'll get some funny coefficients maybe, because it seems like a jobless thing to do, but it is not. In the sense, you'll understand it's not a useless thing to do. Finding these for x cube and x. So we today just found it for arbitrary polynomial, right? You took an arbitrary polynomial and you found what it is with respect to, when written with respect to these, what are the coefficients. But I want to present something in some sort of a linearity. When you try to write this in terms of these, and then x square in terms of these, and then x in terms of these, how you could use those four informations to effortlessly find this answer for any other polynomial in a very effortless way. Okay, and some matrix thing will come in through that. But anyway, maybe I will not do it for the time being. Later when we do matrices, because matrices are the correct thing to. Anyways, let's not make all those comments now. Yeah. So is there any questions? I've not given any homework today. Just a few things that you should just practice. Okay. So are there any questions? So no. Okay. So just pick any chapter on polynomials. Lagrange interpolation is a keyword. We should just see, you will find things. And yeah. So yes, and just a minute. No, it's better in the test. I will give some questions. I'll make a test. Maybe tomorrow I'll make, because tomorrow is a holiday in the sense that everything is closed. Libraries, play, and college, obviously. So I'll make a test, and through that you'll get some practice and you'll pick up new things. Okay. All right then. If